I'm going to show you how to solve an exponential decay problem. I will be showing you how to create a table, recursive rule, explicit rule, graph, and how to create two additional problems along with it. The problem is, you own a 2013 Chevy Malibu and it is worth $20,500 brand new. Each year its price decreases by 8%. So to start, you have $20,500 and it decreases at a rate of 8%, which would be an increasing rate of 92%. For the recursive rule, you will need the start value, which in this case is $20,500, or $20,500. Then you will need the now next rule, which tells you what to multiply each answer by to get the next one. In this case, it would be multiplying by 0.92, so the recursive rule would be start equals 20,500, and now times 0.92 equals next. Next, you have the explicit rule, in which you would have 20,500 as the initial value, then multiply it by 0.92 and put that to the x power. Then 0.92 represents the increase of the car's total price, while the x power represents the number of years you have owned the car for. So for example, you will multiply the initial value of 20,500 by 0.92 to the third power, which would mean if the car was originally $20,500 with a decrease of 8%, it would be worth blank in 3 years. So the final equation would be 20,500 times 0.92 raised to the x powers. Now we will fill in the table using the recursive rule. You could also use the explicit rule, but I prefer the recursive rule. You have the start value of 20,500, and you will multiply that by 0.92 each time to get the next year or the next amount that the car is worth, then the year after that, and so on. You should end up getting 20,500 as your initial value, 18,860 after the first year, $17,351.20 for the second. For the third one, it should be $15,963.10. For the fourth, $14,686.06 and $13,511.17 for the fifth. Now for the graph, we will pick a rate for the amount the car is worth, or the y-axis. I chose to go by 2000s, and for the x-axis, or the amount of years, I chose to go by 5s on every other line. Then you will plot the points in this graph, or in the graph, using the table we completed, which will give you a line curving slightly downwards, such as the one in my example. Now we will solve two additional problems using the recursive rule. The first one asking in how many years the car will be worth $11,435.86. Using the recursive rule, you can multiply until you get the final answer, which would be 7 years total. The next problem asks how much the car will be worth in 9 years. Using the recursive rule once again, we found that the final answer would be $9,679.31 total. That is how you would solve an exponential decay problem. Stay tuned to learn how to solve a linear decay problem.
Hello. Today I'm going to show you how to solve a linear decay problem. Let's say Sally Sue went to the amusement park with $250. She has to pay $45 to get into the park. It costs $5 per ride. How many rides can she go on if she spends $2 on a hot dog, $1.50 on a candy bar, and $3 on a soda? The answer to that would be 39 rides. This is because she starts off with $250, and she has to pay $45 to get into the park. So you just subtract $45 from $250. Also, you have to subtract $2 for the hot dog, $1.50 for the candy bar, and $3 for the soda, and you get $198.05. Then, you subtract $5 for each ride she goes on. So, if she went on 5 rides, then you subtract $25 from the initial $198.5, which means she has $173.05 left. The recursive rule for this problem is next equals now minus 5 with a start of 198.5. This is because you subtract $5 for each ride she goes on. And of course, the start, which is what y is when x is 0, is 198.5. The explicit rule for this equation is y equals 198.5 minus 5x. This is because for each x value, you have to multiply that by -5, which means you subtract 5 each time. And of course, it's minus 5x from 198.5 because 198.5 is the start value. Now we are on to the graph. As you see, the graph is a linear graph, which means it goes in the line. This graph is discrete. That's because she spends $5 each time she goes onto a ride. That's $5 at one certain point each time. So, in order to fit all of the y values, I needed to make it so it went by 15 each time. My y-intercept is 198.5. That's because it's my starting value. So, I used the table to fill out the graph. I will show you the table in just a minute. This right here is the table. You see, there's the start value, which I put right here. The next value was 173.5, which was by 5s. So I put that right there. Now we will solve two additional problems. The first one is, at what point will Sally have spent almost half of what she had started with? The answer to that is, at 15 rides, Sally would have spent almost half of what she started with. This is because at 15 rides, she did in fact spend $123.5. And that is almost half of the initial $250 that she had started with. The next problem is, what if she didn't spend any money on food? Then how many rides would Sally have been able to go on? The answer to that is 41 rides. That is because you wouldn't be subtracting the $2 for the hot dogs, the $1.50 on the candy bar, and the $3 on the soda.
I'm going to show you how to solve an exponential growth problem. I will be showing you how to create a table, recursive rule, explicit rule, graph, and how to create two additional problems or predictions of the future along with it. The problem you will solve is, you own a baseball signed by Hank Aaron that is worth $127,000 to date. Each year the price increases by 13%. So to start out, you have a baseball that is worth $127,000, which increases at a rate of 13% each year. So instead of moving the percentage 2 decimal points to the left and keep it that way as a decreasing decimal, you would move it 2 decimal points to the left and put a 1 in front of it, of the decimal point, to make it a decreasing rate of 113% instead of 13%. For the recursive rule, you will need the start value and the now next equation. The start value is 127,000 and the now next rule is now times 1.13 equals next. As each year the price decreases at a rate of 113% or increases at a rate of 13%. So what it would look like is start 127,000 and now times 1.13, which is the increasing rate, equals next. Using the recursive rule, we can now create the explicit rule. Instead of having to multiply each value by 1.13, you would just have 127,000 multiplying by 1.13 to the x power, in which the x power represents the amount of years you have owned the baseball for. So the final equation would look like 127,000 times 1.13 raised to the x power. Now that we have those two equations, we can now use them to fill in the table. I will go ahead and use the recursive rule because it will be easier to understand. The start, or 0, will be 127,000 because you have not yet had the baseball for a year. Then, using the recursive rule, start equals 127,000. Now times 1.13 equals next. As you can see right about here, we can fill in the table. Let's fill in the table as if we had had the baseball for 8 years in all. The answers you should have had for each year are 127,000 for 0, because you haven't owned the baseball for a year yet, 143,510 for the first year, 162,166.30 for the second, 183,248.92 for the third, 202,070.15 for the fourth, 233,989.27 for the fifth, 264,407.87 for the sixth, 298,780.90 for the seventh, and 337,622.41 for the eighth. Using the data from the table, we will now create a graph representing the increase in price of the baseball signed by Hank Aaron. I have chosen to go up by 30,000 on the y-axis for the amount the baseball is worth, and up by 8 by 1s on the x-axis, representing the amount of years the baseball has been owned. The final product should look like this example of a slightly curved line increasing each year after you plotted all the points in the table. Now we will solve 2 additional prediction problems using the recursive rule. The first one asks, in how many years will the baseball be worth $431,110.06? The answer, after careful thought, being 10 years in all. The second and final problem asks how much the baseball will be worth in 13 years. The answer being, after a lot of thought, $622,047.41 total. That is how you would solve an exponential growth problem. Stay tuned to learn how to solve a linear growth problem.
Today I'm going to show you how to solve a linear growth problem. So let's say Sally Sue's grandmother gives her $250 for her 14th birthday. Sally puts the $250 into a piggy bank. She adds $20 to the piggy every month. How much more money will she have on her 18th birthday if she keeps adding more money at the same rate? The answer to this is Sally will have $960 more. This is because she starts off with $250 and she adds $20 each month. So you have to add $20 to $250 each month also. The recursive rule for this problem is next equals now plus 20 with the start of 250. This is because, like I said earlier, she starts off with $250 and adds $20 each month. The explicit rule for this problem is y equals 20x plus 250. This is because the y-intercept, which is the start value, is $250. And each time you go up the graph on the x value, you have to add $20 each time. In the table, the start value is $250. At 4 months, she has $330. That's because you add $20 each month. Now, using the table, I filled out the graph. As you can see, it's a linear growth problem because the line is going up. And it's a line, obviously. For this problem, the graph is discrete because she's adding $20 at a certain point.
Yeah, you're right. I'm lying. I'm not gonna.
In order to get all of the y values in, I had to go up to 1,600 on the y-axis. To get all the x values, I had to go by 4s all the way up to 56. Now we will complete 2 additional problems. The first one is, at which point will Sally Sue have $2,000 more than when she started? The answer to that is between 8 and 9 years after her 18th birthday. This is because you still add 20 each time, and on her 18th birthday, she has $1,210. And so, $210 plus $2,000 is $3,210. So, that's between 8 and 9 years after her 18th birthday. The next problem is, in how many months will she have enough money to pay for a car that costs $4,870? The answer to that is 231 months. I know it sounds like a lot, but it really isn't.